video, we're going to be going over the basics of electricity, and in this video, we're going to be covering over what resistance is. So let's get started with our video. In our part 1 video, where we talked about what current was, so make sure to watch that video. And then in our part 3 video, we're going to be going over what voltage is, because all three of these have a connection, so that's why we separated them all into 3 different parts. So let's see what we're going to be learning in this part 2 video about resistance. So first, we're going to go over what resistance is. Second, we're going to be going over what current, voltage, and resistance is and what the connection between those 3 are. Third, we're going to be going over conductors and resistance. Fourth, we're going to be going over the factors that affect resistance. Fifth, we're going to be looking at how to measure resistance. And finally, sixth, we're going to be going over what resistors and variable resistors are. So first of all, let's get over what is resistance. So resistance typically refers to the property of a material to resist the flow of electric current. So if we look at this diagram here, this is just a simple circuit here, and we can see that we have a cell, or you can say, so we have a cell there, and we have a resistor here. So let's just say that the flow of electrons is this way, or the flow of current, and when it hits this resistor here, when it goes through, this resistor basically starts to stop or resist or slow down the flow of electric current. So that's the job of a resistor, and we're going to cover more about that later on in this video. And basically also, the resistance of a material depends on its composition, its dimensions, and its temperatures. So now let's go over a resistance example. So when current flows through a high resistance filament of a light bulb, the filament converts much of the energy of current into light and heat. So in this example, what we're taking is a light bulb and the current. And what happens is when we plug this in, then the current from the wall, the electricity keeps on going. And then basically this light bulb has a resistor inside of it, a filament resistor. And basically what that resistor does is that it converts the electrical energy that's coming from here, and it changes that into either light or heat. So from this slide, all we're trying to learn is that resistance, we can use a resistor to change and convert electric energy into some other type of energy, such as in this example we used light and heat. So now let's go over the relationship between current, voltage, and resistance. So if current is described as the movement of electrons through conductors, and voltage is what makes the electrons move, then resistance is what opposes the motion of the electrons. So basically, from our part 1 video, we already know that current is just the movement of electrons through conductors, through the copper wire, for example. And then voltage, or we're going to cover in our next video, voltage is basically just the potential difference, which makes the electrons, which pushes the electrons to move. And finally, resistance is just what resists or opposes the motion of electrons. So now let's look at the relationship between conductors and resistance. So a good conductor has low resistance. So for example, a copper wire. So why does a good conductor have low resistance? So if we take the example of this copper wire, if we think about our circuit, we know that copper wires are really good conductors, and they allow the flow of electrons to go really freely without any resistance. And this is because, and the reason for why it has a low resistance is because the electrons are moving freely without any hesitation to get pushed back. So a good conductor has really low resistance. On the other hand, a poor conductor or even an insulator has really high resistance. An example we're using for this is glass. And this is because that if you were to pass current through this, then it's not going to be able to move freely compared to a good conductor like a copper wire. So that's just the connection between conductors and resistance. So now let's cover over the factors that affect resistance. So there are many different factors that can affect resistance, and the first one that we're going to be covering is material. So how does material affect resistance? So due to the structure of a certain material's atoms, some metals will allow electrons to move more freely than others. And we already know that a copper wire, so we're just going to take an example of that, a copper wire will allow electrons to move way more freely than other such materials, so that's why materials can affect resistance. So the second factor that affects resistance is cross-section area. So as the area goes up, then the resistance will lower. And this makes sense because the more area we have, the more freely the electrons will be able to move, which means that our resistance will go down as the area goes up. And on the other hand, if our area was going down, so the cross-section area was smaller, then our resistance would go up that way. And let's see for length. So the next factor of affecting resistance is length. So as length goes up, then resistance will also go up. So if you think about it, if we have a really long copper wire, the resistance is going to go up compared to if we have a really short copper wire, because there the electrons are going to have to move even more. So as length goes up, resistance will also go up. Now let's talk about temperature. So as the temperature goes up, then resistance will also go up. So these are just 4 factors that affect resistance, and there's many more different factors that also affect resistance, but we just went over the 4 main ones that do affect resistance. Now let's look at how you can measure resistance. So electrical resistance is calculated by finding the ratio of the voltage across the load to the current through the load. So basically, resistance is going to be equal to V divided by I, which is basically the ratio of the voltage across the load. So here, I is equal to the current in amps, so 1 amp, or you can even say 1 coulomb per second. V is the voltage in volts, so you can say 1 volt or 1 joule per coulomb. And R is the resistance in ohms, so 1 ohm, or you can say 1 joule second divided by coulomb squared. So now let's talk about a resistor. So here's just an image of a resistor. So in electronic circuits, resistance is useful for more than just changing the energy of moving charges into heat or other sources of energy. One very common type of electronic component, which is the resistor, is basically just used to control the current or voltage to suit specific needs. So that's just a little bit about what the job of a resistor is. And now we're going to talk about fixed and variable resistors. So a variable resistor does not have a fixed resistance, and the resistance changes in response to the temperature, light, voltage, or some other variable. And here we're just taking an example of an adjustable light for a lamp, for example. So if you're able to dim the light or make the light really bright, so if you're able to do that, then there you have is a variable resistor. So since there isn't a fixed resistance and you're able to change it, that's what makes it a variable resistor. And variable resistors are used in a wide variety of electronic devices, from light dimmers and motor speed controllers. And there's many more, obviously. So that's basically what a variable resistor is. So that's basically it for this video. So thank you so much for watching and try to be useful, and we'll see you guys in the next part 3 video.